All right, this video is for day 2 of our end of the year review unit, and for the first few days I want to continue to remind you of the unit. You have homework grade and a quiz grade. Quadratics, you're going to be doing 2 of the 3 constructor response questions for a grade of 0 through 10. 9 proficient, 7 for apprentice, 5 for not answering. And that, all of those constructor responses will eventually add up to the 100-point quiz grade. And then 196-point homework, that comes from the multiple choice questions, which I've already started the front page, some work that we'll talk about in just a second. But the first page, again, of the multiple choice is always to prepare you for the constructor responses you have to do in that unit. So let's take a peek at those real fast. The first question requires solving a system of inequalities, so you'll have to graph it, show your work algebraically, solve that system algebraically for the points where they intersect, and then explain your work. And all of that is described in the first 3 multiple choice questions. And then the second question is all about imaginary units and doing work with those, showing work and explaining at the end. And that work is illustrated in number 4, multiple choice. And then finally, the third constructor response is about translating, moving a picture left, right, up, down, reflecting over the x-axis, showing good things. And we'll talk about those in 5 and 6. So we've already finished question 1 a couple of times, so I just wanted to put that work up here and then discuss it. The first step, they told us that y2 minus y1 equals 2. So if that's true, you can take y2, you can take this quantity and set it there, substitute it there. You can take y1, which is the 2x squared minus 2x plus 5, and put it there, and then subtract those two things, and it should equal 2. So in the next step, you've got the first thing minus the second. Just be careful that when you distribute the negative sign to the second parentheses, you change the sign to -2, +2, -5. Then I combined like terms, the 3x squared and the -2x squared, and got x squared. Combined the -5x and the +2x and got -3x. And then combine the +7 and the -5 to get +2. Solving any quadratic, it has to equal 0, so that's why I subtracted 2 to both sides and got x squared minus 3x. We could put that in the quadratic formula and we'd get 2 answers. We could put that on the graph of a calculator and see where it crosses the x-axis. We'd get 2 answers. But when given the choice, I'm going to factor the g x equals 0 and x equals 3. For this problem, they told us that x has to be bigger than 0, thus the answer is 3. Now the connection to the constructor response is this. You're going to have to do this work that we just did in part B of number 1. Part B, to find the points where they intersect, you'll have to take this quadratic, y1, the first one, and the second quadratic, and set them equal. Ignore the less than. You're substituting those 2 quadratics to equal one another, and when you solve that algebraically, you'll get 2 numbers for x. Pretend they were 0 and 3. Will be 0. How do you find the y that goes with it? We will then take that x value 0 and plug it back into one of the original 2 problems for x and find the y that goes with it. So then algebraically, you've shown the point is 0, -5. That's what it'll be on the constructor response. It'll be no secret because you should have already graphed the picture where provided over here. And you'll already know they're crossing 0, -5. That's algebraically how to get them. All right, then moving on, question number 2. This one actually got me the first time I worked it. I made one little mistake and got the wrong answer A. But read the problem, and it says you don't have real valued solutions, so the answer can't be A. It has to be imaginary answers, so the answer is B, C, or D, multiple choice-wise. They are solutions to the system that's given. So what I did was took the system that was given and got y by itself by adding 3 in the first one, and then adding y in the second one, thus the y values are by themselves. And now I'll and set -x plus 5 1 minus times the quantity 1 minus x plus 3 equal to the quantity 2x squared plus 3. To solve any quadratic, you need to set it equal to 0 to solve. So I'm to distribute, combine like terms, blah, 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 and get this to where every term is on one side. So I'm going to pause the video and do that and kind of show you what happens. So as you see, some work is all I've done is FOIL. I've foiled the first two parentheses, find their x and negative 5x. I'm going to take the negative that's in front and distribute it, which will change all of those signs. So it becomes positive x squared plus 4x and minus 5 plus 3 equals 2x squared plus 3, and finish it from here. Combine negative 5 and 3, so x squared plus 4x minus 2 equals 2x squared plus 3, and get everything on one side so we can solve this quadratic that equals 0. I prefer to keep my x squared positive, so I'll subtract x squared, giving me an x squared on the right, which means I'm going to subtract the 4x and add the 2 as well. Subtract the 4x and add the 2. So there's not an x term on the right side, so I'll still get negative 4x. But there is a 3 and a 2 to combine and get plus 5. Now we start looking. Let's see. Be tempted. In fact, I just for a second there was actually tempted to try to foil this. LOIF it, I'm sorry, and it would LOIF to x minus 5 and x plus 1. But here's the problem with that. If I have minus 5 here and plus 1 there, it won't give me the plus. So that's how I can see I might get the answer A. So it won't factor. There's not a real answer. So the only way to finish this is the quadratic formula. So I'm going to plug the quadratic formula, opposite of B, plus or minus the square root of something over 2 times A, so over 2. The discriminant would be B squared, so parentheses negative 4 squared minus 4 times A, which is 1, times C, which is 5. The discriminant is negative 4. And if you remember from our rational unit, or radical unit, 4 under square root pokes 2, so 2i divided by 2. But the 4 and the 2 get divided, and you get an answer of 2 plus or minus I, so you get the answer D. And I'm going to stop the video here since it's getting close to the 10-minute mark. So that covers the first two. Actually, I'm going to go ahead and do one more. Sorry. Go ahead and do one more. That way, this will cover constructor response number 1. Question number 3. The only thing I really wanted to review with this is how to determine where to shade. All right, this has an H value of 3, so H equals 3, has a K value of negative 2. Again, that's the Y equals A times X minus H squared plus K vertex form. So according to this, the 3, negative 2, the vertex is at 3, negative 2. Let's see, C does not have a parabola that's at 3, negative 2, and neither does D. This is 3, negative 2, this is 3, negative 2, so it has to be A or B. And then it says greater than or equal to. Well, when we studied this, we said you would shade greater than or equal to. You'd shade the line itself, so it'd be a solid line. And greater than, the Y's are greater than above. So we would say greater than or equal to means shade above. And if you're looking at example A, if you shade above this parabola that I'm highlighting in blue, you would shade up here. So you still may be tempted that it's A or B. Actually, it can't be A, but we'll just continue with the next one that says less than or equal to, and that would be shade below. So, and let's confirm the vertex. H is negative 1, K is negative 1. So yeah, negative 1 matches that parabola. And it's shade below, so shade below the red would be down here. So it's going to be answer B. The shading overlaps. Above the blue, below the red, it's going to overlap in that kind of horseshoe, or in that H-looking shape, if you will. But what's tricky about the constructor response is you have to decide the direction of shading, and you have to show that work algebraically. You have to show the work to decide that direction. So you'll have to show it algebraically like we did when we first started this by plugging in a point 0, negative 10 to prove that you can shade that or not that side. I can help more with this when I get back if you need to remind you how that actually works. But now you can remember where to shade based on what we talked about, shade above, shade below. So that video basically covers the first constructor response. So I'll